What up, y'all? We're back with a practice of multiplying a binomial by a binomial. Bi means two, nomial means term. So here we've got two terms, subtraction. There's a multiplication inside, two terms, subtraction inside. So this is a binomial multiplied by a binomial. This is yet our third example. And remember from previous lives, videos, when we start a math problem, what we're going to do is just read the entire problem out loud to ourselves, multiply the following and simplify, parentheses 6m minus 2, end parentheses, the entire quantity times quantity m minus 4, end quantity. So we want to multiply that out. We've seen that before. We're going to kind of just practice one more time. So here what we're going to do is write that entire statement down in our own handwriting. Screw vanity. I'm gonna put my glasses on, kind of blind without them. Someday when my kids get older, maybe I'll fix my eyes. In this situation, we're going to use the same process, and we're setting ourselves up for inquiry, interest, and intrigue. I'm really intrigued by a question underneath this. So remember what we did last time was kind of chunk information. So we thought about the entire chunk on the right-hand side as one unit. And then we thought about the chunk on the left-hand side as a subtraction, just like distributivity. And we see there's a subtraction there and a multiplication outside. The multiplication is on the right. So we're actually going to pass the multiplication to the left-hand side. We're going to pass that through, which becomes 6m times m minus 1 minus 2 times m minus 4. And this was called right distributivity. So that was the property that we saw previously. And we might just do a recall for ourselves, just to remind ourselves that if we have a minus b times c, this is a super powerful thing to do in mathematics. When you're learning to use formulas, every time you use it, write down the general principle for yourself. So this is a times c, a times c minus b times c. And we might as well use colors. Colors make the world go round. A life in full color is so much more fun than a life with only one color, right? So here we see the chunk on the right. We're passing that chunk into the A and we pass it to the B. And we maintain that sign inside, which is exactly what happens, right? That sign stays. So here, m minus 4 is playing the role of C, 6m is playing the role of A, 2 is playing the role of B. And notice I'm reviewing information as I'm doing this. I'll always kind of testing myself and make myself work for it. Okay, so that was called right distributivity. Maybe we call it RD for short, right distributivity. And we also had left distributivity. So now what we're going to do is chunk information in a different way. We're going to think about the chunk on the left. Here's a multiplication, there's subtraction. So here is on the right now, a minus b. And if we remember what left distributivity, let's see if we can do this off the top of our head. So always testing myself to see if I can remember. So I have a outside of b minus c. Chunk on the left, there's A. Chunk on the right, there's B minus C. And then what I'm going to do is distribute A into there. So A times B minus A times C. So I'm going to pass that through. So in this situation, this is going to be 6m times m, which is 6m squared. M times m is n squared. 6m times minus 4. So 6 times minus 4 is minus 24m. And then over here, minus 2 times m would be minus 2m. Minus 2 times minus 4 is plus 8. And that was by left distributivity. So now I'm just kind of reminding myself what I'm doing here. All right. So remember now what we're going to do is we have this, we've multiplied out the two binomials. We have this 4-term polynomial, but we see we can simplify. So in particular, we call these two terms, negative 24m and negative 2m, we call those like terms. So if I take $24 from you and then I rob another $2 from you, before you call the cops, you might say, hey, this guy robbed $26. So in other words, negative 26m plus 8. And that process, these two things were called like terms. And what do we do with the like terms? We combined those together. So this was combining like terms. So that's kind of the nerdy way to talk about that. So notice we're just going real slow through the different parts of this process. And that's actually my simplified version. So this was called a product of binomials. Bi means two. Nomial means term. So now I'm into my nerdy language, right? And this was called a trinomial. And specifically, it's what we call a quadratic trinomial. For those of you Spanish speaker viewers, cuadro is usually with a C. Cuadro is square. So check it out. Quadratic means square. Trinomial means 3. So it's a 3-term polynomial whose highest degree is 2, quadratic trinomial. And specifically, it's what we call in the form ax squared plus bx plus c, where a is 6, so the term in front of the squared term is 6, b is negative 26, and c is 8. So now all of a sudden, I'm introducing these kind of nerdy language as a way to describe the structure of the problem that I'm looking at. Now, this is where things start to get interesting. And I know what you're going to say. They've been interesting the whole time, man. And I'm with you. I get it. But remember that one of the things, so we're developing abuelita language. We're kind of describing it as if we would talk to our abuelita, our grandmother. We're really getting nerdy in this one. We're starting to kind of formalize the discussion that we've seen. We don't really have a visual representation other than kind of what's going on here. I kind of challenge you viewers, if you can come up with something visual to describe this, I'd love to see that either in the comments or another video or etc. We've got some symbols. We're starting to kind of write in symbols. And then this is where intrigue happens. And specifically, I want to notice something. Notice the sequence of steps for this. So we're going to start with a product of binomials. And then step 1 is to do either right or left distributivity. In this case, we did right distributivity. Step 2 was to do left distributivity. Step 3, I'm starting to write like a doctor, huh? Let me not do that. So this is called combine like terms. And then we ended this process with what we called quadratic trinomial. Okay. So this is what we're going to call the forward direction. So we're going to call this the forward direction. And I want to kind of sharpen what you might call a pattern of intrigue or a pattern of interest in algebra, which is one of the really interesting things about algebra is that when we go forward, we also think about going backwards. So it's not only that we're thinking about like, how do we do an operation, but it's also how do we undo an operation? So how to do operation. And in this operation, we call that the product of binomials. So the question would be, and let me do my questions in red. What is the inverse of this process? Or another way to say that question is, how might we invert our process? Okay, well, we could try to reinvent the wheel, right? We could say like, okay, well, let me try to do another problem. But the claim is that every time you have hard-fought mathematical genius inside of you, and I claim you have genius inside of you. I believe that. I believe you are a mathematical genius. I believe you could get a PhD in mathematics if you want to. I believe you could use mathematics to make billions of dollars if that was exciting. I would recommend maybe instead of making billions, you make a nice living for yourself and donate the rest to the US government so we could pay for all the other things we need to do, right? The role of wealth is not to increase your personal value, but to contribute back to others in society who might not have that. That's something that I believe. But regardless, no matter what you do with your genius, one of the things that's really interesting is when you have genius, use that as a way to build more. So in particular, we've already done all this work on this problem. What if we flipped the script? So here, instead of thinking about going forward, starting here and ending there, what if we went backwards? Direction. And we'll call this how to undo the operation that we're working on. This is a major theme in algebra. Whenever we learn to do an operation, we also are thinking to ourselves, what's the opposite of that? How would I undo that operation if I needed to? So let's think about this. Let's reverse our steps. So the end becomes the start. So we start with a quadratic trinomial in ax squared plus bx plus c. Step one, well, let's see. Step one would be to undo combining like terms, right? Because from start, step one, step two, step three. So step one would be undo combining like terms. Okay, step two, undo left distributivity. Step three, undo right distributivity. Really not that hard, right? This is, well, our grandmother would have had to kind of gone along with this, but we're literally just undoing these things. And then the end would be where we started, which is a product of binomials. All right. So we'll call this page one, and we'll call this page two. And let's just literally reverse the process. Let's go, we start with 6m squared minus 26m plus 8. That's the thing we ended with last time. And then, well, what was this? What did we do to combine like terms? So we split 26m into two different pieces. So let's go ahead and write that. Split negative 26m equals negative 24m minus 2m. The two pieces from combine like terms. Okay, so now this would be 6m squared minus 24m minus 2m plus 8. Okay. So then what did we do? Well, then what we did is, let's check this out. If we go from here to there, in this case, we passed 6m to m and we passed 6m to 4. And that's how we got 6m squared minus 24. What are we doing in the reverse? If we started with 6m squared minus 24, we're actually pulling out 6m from each term. So in this case, we would take 6m out, and then we would do m minus 4. So notice we pulled out 6m from each of the first two factors. So that we called factoring. We've seen that as kind of pull out 6m from each term in the first group. And what do I mean by the first group? Well, remember, we're trying to undo this process, and we were undoing left distributivity because of the way that we passed out that m minus 4. When we did 6m times that, we had kind of a group of two terms. So this thing right here, we might call group 1. And could you guess what we call this then? We might call that group 2, right? And so when we kind of, after we've gone here, we're thinking like, how do we turn group 1 back into a multiplication problem rather than a subtraction problem? And the way that we did that is we factored out the 6m. Factor out 6m. Okay, well, here, so there's group 1, literally the exact same process in reverse, right? All right, well, this then must be group 2, right? So the question would be, when looking at group 2, what are we going to do? Well, what did we do to get group 2? We took -2 and distributed it in. So now the question is, if we start with -2m plus 8, how are we going to get it back into the left distributive form? We're going to factor out a -2. -2 outside of m, because -2 from -2m is m left over. -2 divided by +8 is -4. So factor out -2 from group 2, right? So what we did is, the first thing we did is undo combined like terms. The second thing we did is undo left distributivity, and we did that by grouping. So in fact, what we did is we factored from the first group and we factored from the second group. We factored from groups. We might call that, and in fact, many nerds do call this, factor by grouping. So notice, factor by grouping is the inverse operation of left distributivity. How did we get there? Well, we kind of saw the sequence of steps. We thought, if I want to go forward, this is how I do it. How do I undo that? Well, I just undo each sequence of step by writing in the opposite direction. And then literally we're thinking to ourselves, what are we doing in each step? In this case, we're factor by grouping. Okay, so the next thing that we might want to ask ourselves is, factor by grouping was to take the first group and pull out the 6, take the second group and pull out the -6m, second group and pull out the -2. But check this out. These two chunks are identical. Those two chunks are identical, just like these two chunks were identical. See it? This was the forward direction. And so the question is, what if, so here we've started here, we've gone there, we've gone there. What do we do to go backwards? Well, we undo right distributivity. So specifically, we pull this chunk right here is identical. We pull that off and we're left with 6m minus 2, right? Because m minus 4 was here. There's a 6m there. So when I pull that out, when I factor that out, I get a 6m. There's a -2. When I pull out m minus 2, I get a -2. So that's 6m minus 2. Notice this was a product of binomials. So this was also factor by grouping. The two of those together, when we undo left and right distributivity, that is entirely called factor by grouping. There's two steps of it. First is to group both together and look for a common term in each group. And then the second is assuming that these two terms that we get are the same, that's where we pull them out. So that's how we do that. The one thing that we haven't talked a lot about is combining like terms. So specifically, one of the questions would be, if I started here, the only reason I knew that I was going to do 24 and 2 was because I actually had that from the work that I did forward. But imagine for a moment that I covered that forward work up and I asked myself the question, how do I split 26 into two numbers that will produce those exact same terms there, right? Like what could I do to split this middle term into those two terms so that I could factor out the same copy in the factor by grouping? And that's a little bit more interesting. And let's ask ourselves that question. So let's go here, question. This goes to intrigue, right? We're starting to really get curious. How does the middle term show up in the product of binomials? So when I thought about 6m, in this case, it was 6m minus 2, and then m, what was it, minus 4? This is where we might want to be a little creative. This is where mathematicians can do some fun work here. So let's think about where this comes from, right? So there's kind of 4 terms. So 6m, let's skip right to those 4 terms. So this would be 6m squared. We'll call that term 1. 6m times negative 4, which is the outer term. So this is the first part of this. So that's going to be 6m times negative 4. So that's term 2, which folks that do FOIL, we call that the outer term. And then negative 2, so this is negative 2 times m. That's going to be term 3. And that's what we call the inner term. And then, of course, we're going to have negative 2 times negative 4. That's going to be term 4. And that's the last term. All right. So we can simplify this, of course. We can say that this is going to be minus 24m minus 2m plus 8. Okay, so let's check this out. When we combine like terms, I actually kind of need some structure here. So let's generalize. We're trying to figure out what the pattern is between the first 2 terms here, the second 2 terms here, and the combined like term structure. And in order to do this, I actually want to suggest, I suppose we could say, a more general form of this. So what if we were to do something like this? What if we were to do Cx plus D? And why don't we do C1 and D1? And then C2x plus D2. Right? So in this case, m is the variable. So we call this thing the variable. And then these are the coefficients. The thing in front are the coefficients. Dunk, dunk. So over here, this is the variable. And then these are the coefficients. C1, D1 coefficient. C2, D2 coefficients. And variable. Okay. So let's look at that same term. So what I'm going to do is C1x times C2x. So this is going to be C1, C2x squared. That's term 1, which is what we call the first term. And then let's check this out. C1x times D2, C1x times D2. That's going to be term 2, which is what we call the outer terms. And then, of course, let me put these a little closer together so it's easier for me to see. So here I've got C1x d2, and then I've got d1 c2x. And then over here, check this out, d1 times d2. Just lock this real quick. So this is called inner. And this one right here is term 4. And that's called last. Okay. So let's go ahead and simplify this a little bit. So this is C1 C2 x squared plus C1 D2 x plus D1 C2 x plus D1 D2. When I combine like terms, notice I have C1 C2 x plus C1 D2 plus D1 C2 plus D1 D2. And notice this is going to be ax squared plus bx plus c. So now all of a sudden, we have this really special relationship between the individual entries in both binomials, the C1 and D1 entry and the C2 and D2 entry, and the values of the AC, right? And so the question is, well, where do these values come from? Well, we know that C1 D2 plus D1 C2, those two things together are going to be equal to B, right? And then what we're going to look for is we want to find these values. We want to find when we factor out. So right here is the factor, right? So right there, notice that C1 so C1x plus D1, C2x plus D2. When I look at that, that's C1x times C2x plus D2 plus D1 C2x plus D2. And then that's the distributivity, right? I bring in this C1x, C2x plus C1x D2 plus D1 C2x plus D1 D2. Okay, so check that out. These numbers, the C1 and D1, C2 and D2, when I'm trying to figure out which two numbers these are, you see that? So my real question is, how do I split this number B into two different numbers such that I can factor out the numbers that I want? And what I wanted to show you was, in this relationship, I have A is equal to C1, C2. B is equal to C1, D2 plus D1, C2. And C is D1, D2. Okay, so check this out for a second. A times C is equal to C1, C2, D1, D2, right? And B is equal to C1, D2 plus D1, C2. Well, check that out. I'm looking for two numbers such that when I multiply those numbers together, I get A times C. And when I add those numbers together, I get B. Right? So if I think about these as my numbers, here's my numbers. I want C1 times D2 and D1 times C2. If I add those numbers together, I'm going to get B. When I multiply this factor C1 D2 times D1 C2, I get A times C. So add together, I get B to form B. Multiply together forms A times C. Okay, well, let's go ahead and test that. So let's go back up here. So this was a general approach. And then let's go back to our example. Let's return to our example. Okay, so here we go. We had 6m squared minus 26m plus 8. Okay, let's specifically identify A equals 6, B equals negative 26, and C equals 8. All right, and so we wanted two numbers to split negative 26m into two factors and set up factor by grouping. We want to find two numbers that add to B and multiply to A times C. Okay, well, what was B? B equals negative 26. What was C? A times C is 6 times 8, which is 48. Okay, so let's start with products, or excuse me, factors of 48. Okay, well, we know 48 for sure is going to be 1 times 48. Those could both be negative or both be positive because it's a positive, right? Do any of those get remotely close of negative 26? In fact, because this is negative, I'm going to go ahead and say both of these should be negative, right? Because the only way to add to a negative number and multiply to a positive number if I have two negative numbers. But negative 1 minus 48 is negative 49. That's definitely not equal to negative 26. So that's not it. Okay, let's try another one. One of the best ways to do this, let's just go ahead and divide by 2. 48 divided by 2 would be 24. Minus 24. Oh my God, we got super lucky. And minus 2 minus 24 is minus 26. Ding, 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 ding. This is the one we want, which implies if I take negative 2 26m, I could write that as minus 24m minus 2m, right? So all of a sudden, we now have an algorithm to split up the middle term, which was part of our reverse process, negative 6m squared minus 26m minus 8, excuse me, plus 8. Well, what did we just, I'm coming, I have a 3-year-old out there. He's just got home from school today. So here, negative 6m squared minus 24m minus 2m plus 8. Notice these are the exact numbers that I would have wanted to search for had I had the information of the forward problem. In other words, what we've just done there is ask ourselves, if I had the forward problem, if I was trying to multiply two binomials and I wanted to get down to the end, which is a quadratic trinomial. We know the steps: right distributivity, left distributivity, combining like terms. We asked ourselves this really interesting question. I think it's pretty interesting, which is, if I know how to go forwards, can I reverse that? Can I undo that? So instead of starting with polynomials and getting down to a quadratic trinomial, what if I started with a quadratic trinomial and wanted to work my way backwards to a product of binomials? In other words, I want to undo combine like terms. I want to undo left distributivity. I want to undo right distributivity and get here. These two, we saw that is kind of lower hanging fruit. That was called factor by grouping, but this one was kind of hard. The only reason we could split -26 into -2 and -24 was because we had done the forward problem. But imagine that I had given you this and I asked, split that number into 2. Well, we did some algebra. We did some algebraic thinking, which was to look at the specific problem, generalize. So really think about what the structure of each binomial was by introducing some notation. Don't worry. I wanted to show you this. I think you're sophisticated enough to understand this. I believe this about my students. I think you can do fantastic mathematics. I think learning how to do math is a lot like learning how to do athletics, watching somebody do it and trying stuff that you would never think about yourself, right? Think about a basketball player. Guaranteed, if that person's serious about basketball, they're flipping on NBA and probably watching Steph Curry shoot free throws or 3 points, right? Because the point is, when you watch somebody do it, you kind of get ideas and get structure that you wouldn't do alone. And so in this situation, we were asking ourselves the question, if I multiply these out and get a structure ax squared plus bx plus c, how would I split b? And in order to split b, we see that that split is going to be c1 d2 plus d1 d2 c2, no matter what those values are. That's for any value under the sun. And then the crazy thing is those same exact factors show up here. A is going to be c1 c2, c is going to be d1 d2. So in other words, if I want to know how to split, I can ask myself the question, find two numbers, find a number c1 d2 and a separate number d1 c2, such that when I add the two numbers together, I get the coefficient b. I get the linear factor, the thing in front of just the variable to the first power. But when I multiply those two together, when I multiply this factor and that factor, I get the product of a times c, which is exactly what we see, right? c1 d2 times d1 c2 is indeed c1 c2 times d1 d2. That's the same thing. And so that's kind of the way that we split those. We look for two numbers. When I add those together, I get the coefficient b. When I multiply together, I get the coefficient c. And here it is. So we're going to call this mechanism that we just developed here, undoing combining like terms, we're going to call it the AC method. We actually just developed our own method of undoing multiplication. This is also called how to factor a quadratic trinomial. Well, we start with a quadratic trinomial, we run the AC method, then we factor by grouping, and then we end with our product of binomials. That's the mechanism. So let's go ahead and write that out in general. This is page 6 already. To factor a quadratic trinomial into a product of binomials, we start with quadratic trinomial. Ax squared plus bx plus c. Step 1, we're going to call run the AC method. And that's going to be to find two numbers that multiply to A times C and add to B. Okay. Step 2 is going to be factor by grouping. And really this was steps 2 and 3 because there's 2 different parts of that. And then end product of binomials. All right. We're going to revisit this over and over and over again. And notice all of this work came from inquiry, came from curiosity in our soul, which was, if we know how to do something in the forward problem, can we undo it, right? And I do want to highlight that satisfying curiosity in math is an expensive process, so it actually takes a lot of work to do this. But I also want to encourage you, when you're starting to play with math toys, let your mind roam and kind of allow yourself to ask that question. Okay, we'll come back to this in future videos. We'll actually show how to run the algorithm and how to run the steps. Community challenge for this video in the comment section below. Why don't you share some comments about what you noticed that was interesting in this video? What kind of caught your attention or took you off guard, or something that, that made you smile a little bit? Thank you so much for your attention, y'all. I'll see you in the next video.